Alright, here's the video. We're going to do page 1 video. It says, determine whether this is a function. Now probably the easiest way is to maybe make a mapping diagram when we've got specific points like this. It says 3 is mapped to, this is the domain, this is the range, 3 is mapped to 3. 4 is mapped to 2. 5 is also mapped to 2. So my analogy in class was kind of like dating, where we have two people chasing the same other person. That's okay. That's not two-timing. It's when domain goes to two different things in the range, which some of you thought 4 showing up again means it's going to be two-timing. Well, but 4 went to 2, the same range value. So it's just emphasizing that 4's matched to 2, or chasing 2, or whatever you want to call it. And then there's 7 going to -1, and 8 also going after 2. So 2 is something that numbers like 4, 5, and 8 are all getting mapped to it. That's okay. It's not two-timing. For each domain element, there's only one range element it's mapped to, so this is a function. Because each domain element is mapped to only one range element or number, or whatever you want to call it, member. Okay, that's 1. Number 2, a lot of you said vertical line test. Some of you said holes. Holes do not make it not a function. A function has to be, for every domain element, it's mapped to one and only one range element. 3 mapped only to 3, can't be mapped to anything else then if it's mapped to 3. This says 2 is mapped to 2 and 1 is mapped to 1.3 or something, but back here at -2, there's no value here, but there is one up here, so that one's okay. But be just to the positive side of -2, or the greater side, if you want to call it that, positive side of x equal -2, there are some places in here where there is more than one range element for a domain element. In fact, there's, in some places here, there's 2 up here and 1 down here. So there's several places that it doesn't, you could have also said, does not pass the vertical line test near x equal -2. And then I know where you're going. Or you could point an arrow, does not pass the vertical line test here, and point an arrow there. Okay. Number 3. Number 3, we have to, make sure it's there, we have to look for things that cause problems for the x. This is a division problem. This is a square root problem. Those are examples of the 2 things that can cause problems. Division by 0. We don't care what the numerator of a fraction is. It can be any number. The denominator cannot be 0. So 2x plus 3 cannot equal 0. That means if I subtract 3 from both sides, 2x cannot equal negative 3. Divide by 2 and I get x cannot equal negative 3 halves. So that's what it can't equal. So what can it equal? Well, if we write in set notation this, set whose elements are numbers such that the numbers are not equal to negative 3 halves, then it can be anything else, and that would be okay. Or I could say in interval notation, it goes from negative infinity up to negative 3 halves, not including the negative 3 halves, union from negative 3 halves to infinity, and that leaves out negative 3 halves. That's interval notation, that's set notation. Either one would work. You could also write all reals except negative 3 halves. So there's the 3 ways you could have written that one. On the part B, some people couldn't figure out that this is 3a and problem 1 is clear back up here. The domain, well, the domain are the x values, those numbers, 3, 4, 5, 7, and 8. Not the numbers in between them. Not 3.5, 3, not pi, not any of the numbers in between. So we can't necessarily do something like this, or between negative 3 and 8 or something like that. It's only, and so we'll just list those numbers, 3, 4, 5, 7, and 8. That's the easiest way to list the ones that it can be. And then C, we have a problem of square roots. You can take the square root of 0. The square root of 0 is 0. So there's no problem with the inside of this square root being 0. There's no problem with the inside is greater than 0, positive numbers. The problem is square roots of negatives. So the domain has to be something that allows 4 minus 2x to be equal to 0 or greater than 0. As long as the stuff inside is 0 or greater, we're okay. So what does this tell us? Well, solving inequalities is like solving equalities. You get rid of, this is multiplied and then add. We get rid of the added stuff first by subtracting 4 from both sides. And we're subtracting a negative 4. We don't flip the sign unless we multiply or divide by a negative. Next step, we have to divide by negative 2. That's going to cause the sign to flip, and we're going to get x less than or equal to negative 4 divided by negative 2 is positive 2. Now I can write that in set notation. I can write it in interval notation. Less than negative 2 is negative infinity up to 2, including the 2. Or I could say all reals that are less than or equal to 2. That's the 3 different ways you could answer that one.